computer so I can post it. All right, so we're gonna go here. Sure. All right, so that'll be our lecture day. It's a little bit shorter. It's only a couple. All right, what did you like to see? Go ahead.
Number 1.
Number on 8E.
D.
D, E. What are we on? D as in dog?
Yeah.
Okay. Number 1. So you want to break this down as prime components. So you know that 50 is the same thing as 2 times 25. 5 is the same thing as that. So you're going to write 2 times 5 squared. Done. Yeah, you start to feel silly going, wait a minute, that's too easy. But that's okay. Yes?
13.
Sorry?
13.
13. That's the one that's 8 to the negative 4/3. Okay. All right, let's get rid of the negative exponent first. So I'm going to make it this first thing. Is that okay? Okay, and then the denominator of the exponent means what root? So we're looking for the third root of 8. What is the third root of 8? 2. So you get 1 over 2 to the 4th. And then 2 to the 4th is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. Yeah.
Can you go for 19?
19? Yeah. Can I move off that one? Okay, number 19. We get negative 32 raised to the 7/5 power. Okay, so the denominator of the exponent means we're trying to find the 5th root. And 5th roots are going to have negatives, okay, because it's an odd number. So 3rd roots, 5th roots, 7th roots. So let's see. I know that 32 is, let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 32 is a perfect 5th. Agreed? So negative 32 would also be a perfect 5th. So that would give me negative 2. And then we're going to raise that to the 7th power. I guess we could do that. We could do that out. Okay, it's raised to an odd exponent, so it's still going to be negative. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is negative 128. Now, friends, that's not impossible to do. I'd say if you get like 3 to the 7th or 4 to the 7th, something like that, you leave it just as 3 or 4 to the 7th. But because 2 is a little bit easier to manage with, I would say if you wrote negative 2 to the 7th, I'd probably circle it and then make a note of it. I don't know if I'd mark it wrong at this point, but the more correct answer, if this was a multiple choice, I would give you an answer of negative 128. Is that okay? Yeah.
17.
17? If I have negative 125, it's raised to the negative 2/3 power. So I want to get rid of the negative exponent. So I'm going to make it this. Please note that when I move it down, the 125 stays negative. So it turns into that. So now it's no longer a negative exponent. The denominator of the exponent tells us what root we're dealing with. So we're looking for the 3rd root. So can I have an odd or a negative number for a 3rd root? Yeah. So what is the 3rd root of negative 125? How much? 5. Okay. So it's going to be negative 5 quantity squared. And notice I grouped it, and I grouped it for a reason, because the whole thing was kind of grouped originally. Then what is negative 5 squared? 25. So I get 1 over 25. So this kind of thing alternates between positive and negative, depending upon which power. If that came out and we were doing negative 5 to the 3rd power, then it'd be negative 125 because it's negative 5 times negative 5 times negative 5. Yeah.
24.
Okay. Six to the 2/3 power times 4 to the 2/3 power over 3 to the 2/3 power. Okay. So all of our bases are different, but we have the exact same exponent for everything. Agreed? So this one might be easier to look at this. And I'm going to focus on this. So I have the third root of 6 times 6, the third root of 2 times 2, the third root of 3 times 3. Okay, so let me just pause there. Does that make sense what I just did? It should be 4 times 4 because I've been. Is that okay now? Okay, thank you. All right, and I guess I could have broken 6 down as well, but I didn't break 6 down. But we're all under the same radical. Okay, so we're under the same radical, so treat this as a fraction. So 3 goes into 6 twice. 3 goes into 6 twice. Is that okay? So the denominator is now 1. I'm looking for 3 of a kind. So 1, 2, 3, and 1, 2, 3. That means a 2 comes out and a 2 comes out. So my answer just overall becomes 4. Yeah.
Could you do it since they all have the same exponent? Could you do 6, like 24 to the 2/3 power over 3 to the 2/3 power? And then you'd get 8 to the 2/3 power if you divide it.
Oh.
And that's still be 4.
What a beautiful mind. So could I do 24 to the 2/3 over 3 to the 2/3? And that would give me 8 to the 2/3. And then third root of 8 is 2, and then 2 squared is 4. Oh, yeah. I love it. Different thought process, same result. There's not one way that's more correct. I bet actually your way is probably more correct than my way because you're smarter than I am. What else would you like to see? Yes?
Like 27.
27? Okay. We have the third root of 2 to the 5th, and we have the square root of 8. Now I'm just going to put square root. Normally you don't have that subscript of 2 there, right? But I'm just going to put it because I'm going to show you how I'm going to convert this. So I'm going to say that this is the same thing as 2 to the 5/3 power. Is that okay so far? I know that I'm going to have something. Can I take 8 and make it 2 to the 3rd power? Is that all right? Which means I could have plugged this back in here, which means I have 2 to the 3/2 power. Is that okay? I have same bases, raise the exponent. So it's tug of war, so it means I'm subtracting the exponent. So 5/3 minus 3/2. Have you been following my butterfly method when I'm doing fractions? I know I've been doing it fast. Let's give you a reminder. So if we add or subtract fractions with unlike denominators, 5 times 2 is 10, minus, because of subtraction sign, 3 times 3 is 9, over the denominator multiplied. 9 minus, that's 1/6. So this comes to an answer of 2 to the 1/6 power. I like that way of adding and subtracting fractions, but sometimes it gets goofed up when you start multiplying fractions, then you think it's the same iteration. It's like, no, top to top, bottom to bottom, because multiplication is different. What else would you like to see, friends? Feel okay about it? Happy? Yes.
22.
2, 2. Third root of 128 and third root of negative 54. Okay, so we're allowed to have a negative third root. Let's see. I don't see this breaking up right away, so I'm going to put this whole thing under a big third root. And I know that I'm dealing with this, so I'm going to move it out front so I don't have to deal with it anymore. Is that okay? So let's break 128. That's 2, 4, 8, 16, 32, 64, 128. So that's 1, 2, 3, 4, 5, 6, 7. That's 128. 54 is 2 times 27. 27 is 3 times 3 times 3. And again, I see it this way sometimes. I don't see the fast perfect cube right away. But it's because I didn't ride a bike with a helmet when I was a kid. I used to not ski with a helmet. I was like total rebel. All right, so third roots. I know this negative is going to be here. So I get a 2, a 2, and a 3 that come out front. Then inside I'm left with just a 4. So negative 2 times 2 is negative 4. Negative 4 times 3 is negative 12. Third root of 4. Anything else, friends? Seem happy? Both of you got it done now?
Almost.
What do you still need help on? I bet you could do 3 pretty easily. 7, 4 through to 16. 2, 4, 8, 16, so it's 2.
Are we getting odds or?
I don't remember.
I think this was all.
It was just odds? Okay, we'll do odds. I don't remember these things. Again, I blame my mom for not having me wear a helmet as a kid. All right, so we feel comfortable with it. Would you get out the notes from last time? Was everyone here last time? So like Monday? And we just have a front and a back. It's 8E, if you forgot it. I have a couple of extra copies. But if you come get one of my last 3 copies, that means that no one in tomorrow's cohort gets it. Okay. All right. Let's go back to time on the board. Maybe section. There we go. So we're going to use the calculator in solving like base and higher power equations. Goal to solve higher base and higher power equations with a calculator and without a calculator. And first one says we want to evaluate the first problem, the 6th root of 4376, but we want to use it with a calculator, and we're going to round it to the nearest 100th, one appropriate, so 2 decimal places. Okay, so first thing you have to recognize is your calculator. Some calculators will find it has a button that allows this to take place. There's a little box, and then you put that in, you put a 6 in the box. If your calculator doesn't have that, you can also recognize that this is the same thing as 4376 to the 1/6 power. So now let's look at where it works on the calculator. Okay, and I have 8 calculators if you ever need to borrow one in class. But you don't necessarily need to go grab one this very second. All right, so I know that first problem is this. Let's see, I'm trying to find my key and it's blurry. So sometimes you can go second catalog and go from the bottom up. It might have it there. Let's see, I don't know if I'm not seeing it right away. So I'm just going from the bottom. So I hit second catalog and I went to the bottom. I'm going up. So I got third root. No, that's not going to help me. Ooh, that one right there. X root. So this one would allow me to go 6th root of 4376 and hit enter. So the answer to this is 4.04. If you can't find that, because that was kind of a little more difficult to find, if you can't find that, we also knew that we could go 4376 caret, and then sometimes it wants it to be in parentheses, sometimes it doesn't. Let's see if it doesn't. It works without. It looks like it'll work without it. But sometimes you might have to do that same thing on the calculator. And it just really depends what year your graphing calculator was made. So all of those are going to go to the same thing. Yeah. Yeah, so you would just give me, or well, it depends. Sometimes, like this one said, hey, leave it to the nearest 100. Sometimes we want you to leave it as exact, which means you'll leave it as a radical somehow. Okay. All right. Problem number 2 on our notes. So we have 328 to the negative 4/5 power. So you could try and find that one iteration, but I think it's easier to just do the caret. So I'm going to do that same thing on the calculator. I'm going to go 328 raised to the, use that negative down here, 4/5. Hit enter. And in this case, it gives me an answer. If I make that to the nearest 100th, so my answer would be 0.01. Right? That makes sense? And again, I could have tried to find the 5th root where I plug it in and gone from there, but sometimes it's easier to just plug it in. And it says solve the equation without a calculator and try and get equal bases on both sides. So now we're leaving the calculator. Hopefully they saw that. So now we want to walk away from the calculator. Okay, so first thing I'm going to take a look at is we want to try and solve this problem. Okay, so we have a power of power on the left side. We have x minus 5, and that's raised to the second. And then we have 16. So sometimes it's a good idea to try and get the bases to be the same. Being that 2 is a prime number, that's what I'm going to try and get 16 to. And I know 16 is 2 times 2 times 2 times 2. 2 to the 4th. So I had 2 to the x minus 5 raised to the second equals 2 to the 4th. Good so far? Now that I have like bases, I know that power to power means I'm going to multiply this in like that. So this is going to give me 2 to the 2x minus 10 equals 2 to the 4th. If I have the bases the same, I can just set the exponents equal and solve. So add 10, divide by 2. So you solve that x is equal to 7. So problem number 4, same idea. 5 is one of my bases. 5 is a prime number. Can I turn 125 into 5 to some power? What do you think? 5 to some power, is that the same thing as 125? If so, what power is it? Third, 5 to the third. Because 5 times 5 is 25. 25 times 5 is 125. So I'm going to get 5 to the 2x minus 4 equals 5 to the third, and I have that x there, so it's going to become 5 to the 3x. Is that okay? Now my bases are equal, so I can just set my exponents equal to each other and solve. Subtract 2x from both sides. So we find that x equals negative 4. Yes?
To do the 5s to go.
Yeah, because they're like bases. Yeah, and I think we're going to get to something that we can't work when they're not like bases, but we'll eventually get to that. Okay. So on the backside, it says solve each equation without a calculator. All radicals and rational exponents should be evaluated mentally. So we can do them. Can I move on? So this works when the bases are equal. When you can get the bases equal to each other, you can just set the exponents equal to each other. Oops. That's the next one, right? Yes. All right. Solve each equation without using a calculator. So notice I have x minus 3 as a base, and I have 8 as a base, and I can turn 8 into 2 to the third, right? X minus 3 is not the same base as 2. Agreed? So what you're going to do on this type of problem is you're going to say, okay, in order to undo this radical, I can do the third root of this side, and I can do the third root of this side. If I do the third root of each side, these cancel, and it leaves me x minus 3. Third root of negative 8 is negative 2. Add 3. So I find I get an answer of 1. And for as complex a problem that is, there's not a whole heck of a lot of steps. For number 6, on the left side, I have 6x to the 4th, and it's subtracting 16. So sometimes when you don't have things grouped together, like number 5 is grouped together because x minus 3 is in parentheses. But number 6, it's not grouped together. So sometimes you want to try and get rid of as much things as possible before you do, like on this case, the 4th root. So eventually I'm going to have to take the 4th root of both sides, but I'm not there yet. So I'm going to add 16 to both sides. So those cancel. What is that? 486. My arithmetic okay? Okay. Now, I eventually want to do x to the 4th, but I'm still not there. 6 is being multiplied times x to the 4th. So if this was back in algebra 1 and we had 6x equals 486, we just have to divide both sides by 6. It's the same rule here. Okay, so all I'm going to do is I'm going to divide by 6, divide by 6. Those cancel. I get x to the 4th is equal to, let's see, 6 goes into 48 8 times, 6 goes into 6 once. So I wind up with 81. Now, when they said evaluate without using a calculator, our hopes is we can just get a whole number out of it. So I'm going to take the 4th root of both sides. Anyone want to take a guess? Yeah. 3? What do you think? It's 3 times 3 is 9 times 3 is 27 times 3 is 81. Cool. So at this point, we can say, all right, 4th root of 81 is indeed 3. Now, if we had, say, something like this, let's say it came out to 4th root of 243. That means that's the same thing as saying this, 81 times 3. So then you would wind up with an answer here of 3 4th root of 3. So that's where you kind of sometimes have to make sure that if it doesn't come out to a perfect, can you break it into a perfect somehow? And I think some of you might start to realize that when we start getting to exponents that are like 4 and above, 2s and 3s and 10s are probably about the only thing we're going to sit there and have you break down. So if I had like x to the 5th equals something, take a look at your number, 2s and 3s first. And you obviously know if a 10 would work because it would end in a 0. Okay, but usually, because if we do anything else, you start getting to numbers that are way too crazy fast big, and they don't become as easy to identify. May I move off this one? I have one slide left. Are you kidding me? Okay. All right, solve each equation using a calculator to approximate the radicals. Round any decimals to the nearest hundredth, so 2 decimal places. Okay, so we want to start solving these before we go to the calculator, okay? So on this one, I would probably multiply both sides by -1 first. That's going to allow me to get x to the 5th equals -81. Is that okay so far? Yeah.
It's just 80, right?
Oh, it's just 80. Yeah, I'm like adding numbers and stuff. Here, we'll mess with cohort B. It's a good thing I didn't say that in cohort B because they wouldn't have caught that. Now they're going to watch the video going, we'll see who watches the video. Just have you know, one of my Algebra 2 videos has been watched 64 times. What y'all doing with my Algebra 2 videos? Come on, guys. Come on, let's get that number even higher. If they get watched like 1,000 times, they get like a nickel from YouTube. I'm kidding. I have no idea if I do or don't. All right, so we got past the stirrup error. Appreciate you looking out for me. All right, my friends, what should we do to both sides in order to get x alone? What do you think? Fifth root, yeah. Hey, can I have a fifth root of a negative number? Yeah. Okay, and so if we can't find that fifth root key, we also have to realize this is the same thing as negative 80 to the 1/5 power. Okay, so we have to realize we have that. So let's go to our calculator. And for the folks that are watching this at home, I'll stop this. I'll share this. Well, it was the what? Negative 80 to the, okay. Now, if you don't want to get yourself in trouble, if you're doing roots with negatives, it might be a good idea to put the negatives in parentheses. Okay. Now, it might have come out correct if we didn't, but what you have to be really careful of is I am taking the fifth root of negative 80. If I don't put it in parentheses, the calculator say, what's the fifth root of 80? And let's do the opposite. In this case, it would have worked. But if you're dealing with a negative number, it's always a good idea to group it. And then you say, okay, 1/5 power. Looks like we came out with 2.40 for an answer, negative 2.40. And I have a sneeze that's coming. Woo! You don't want to see what's inside this mask now. I'm kidding. All right. Let's stop sharing this screen. Go back to this screen. All right. Last problem. Anybody want to take a shot at what maybe we should do first? Yeah.
Add 8.
Add 8. I'll take it. Let's cancel. Okay. We're trying to isolate x. Maybe what should we do next? Divide by 4. Good. Divide both sides by 4. Let's cancel. 4 goes not once. For 107. Okay. Friends, we're going to take the fourth root of both sides. Let's see who remembers the gotcha on this one. Doesn't happen with odd roots, but this has the same property as the square root. If I take the square root of both sides, what do I have to remember? Yeah, positive, negative. That's going to be the same exact property if I take the fourth root or the sixth root or the eighth root. It's the only gotcha in this thing. So if we're going to take the even root of both sides, there has to be a positive negative component to it. Does that make sense? All right, so I'm going to take the fourth root of both sides. And we have to realize that the fourth root is the same thing as 1/4 power. And I'm going to put the plus or minus here. So there's going to be a plus or minus there, just so we know that we go with it. Okay. So just to save time, with this will do it. Just so I don't have to flip-flop screens. Clear. I want 107 raised to the 1/4 power. Okay, so that's going to give me x minus 2 equals plus or minus 3.22. Okay. Almost done with the problem. Add 2 to both sides. And do the arithmetic. 2 plus 3.22 is 5.22. And 2 minus 3.22 is negative 1.22. So I have 2 answers. Okay. So keep your eyes peeled. If you do the root of both sides, you would dislike me a little bit if I took 1 point off if you forgot the plus or minus component, because it seems like such a basic thing. Sorry about that. I'm doing what I do best. I'm getting in the way. You should see me at the mall. I'm this guy the whole time. That's actually how I just walk through the mall, just so I'm already in the dancing mode. Guess whose wife won't let him come to the mall anymore with her? You just embarrass me. Sorry, I'm just having fun. Y'all want to know why I don't go to the grocery store with her anymore? This is bad, but you're totally allowed to do this. So there's always an aisle in the grocery store that has food that is not for my palate. Pickled pig's feet, things like that. So I go to that aisle on purpose. And I grab myself a can of pickled pig's feet. And I look for somebody in the store who's got a shopping cart that's way too full. And I go by and I put that into their shopping cart when they're not looking. And my wife has told me that I'm not to go to the store anymore. What really embarrassed her is there was kind of a guy who was a little bit more, I think he was frustrated he had to go to the store by himself. So I went over by the pharmacy and I found the Depend undergarments, the ones that in case you can't hold your pee. Yeah, they're called Depends. They're like diapers for adults. So this guy was all loud and obnoxious. So I put one of those in his cart. My wife said, "You can't come anymore. That's not funny." I'm like, "No, it's very funny." But so, my friends, what should we have for next time? I don't know. Let's see what we got. Let's see. Sharing. Let's go to share. Let's find that, I guess. Share. Zoom. Worked. Let's go to accelerated algebra 2. So eventually, probably by sometime tomorrow, I will have a week 3 folder, but nothing's due in there yet. So in the week 2 folder, I've had one student that's already completed this. Notice there is a quiz. Okay, the quiz is on Schoology. I say that it's due Sunday, January 17th. Just a little hint. I don't have the due date set in there, so it's not going to cut you off if you wake up at 1:30 in the morning on Monday morning going, "Oh no, it's still open." It'll stay open for you. Okay, but I would like you. Let's see, what does 8E have? Take a look at it. Ooh. I would say for 8E, I think you can do all the problems. Now, I know for a fact that the stretch questions at the very end, we're going to have questions about, and that's fine. So if you get through 1 through 20 and you look at the stretch questions going, oh no. We will definitely do those in class. So my plan between now and a week from today, so Thursday or Friday next week, depending upon which cohort you're in, we will have an in-class quiz. Now, the quiz is 2 parts. What I have planned on Tuesday or Wednesday, depending upon the cohort, is we're going to go over E that I assigned. I will go over any of the review on 8F, but it's not due. But to shorten what I will give you for the quiz, we are going to start the calculator portion of the quiz on Tuesday or Wednesday next week, depending on what cohort you're in. Okay? If you come to class, you don't have a calculator. I have 8 of them in that back cupboard. You're welcome to borrow that. If we run out of those, then I have a couple extra in my office that we can snag. So there is a quiz for you to take care of by Sunday, but that's just a fictitious due date. That's just kind of saying, hey, if you have the opportunity, great. If you don't, it's still going to be open. But come Tuesday morning, I will actually put that quiz score in. So if you didn't do it, then you see your score drop, and then you get that, I hate stirrup feeling. Just do it. And then worksheet 8E, I think you can do them all. The stretch questions at the very end are going to be tougher. We will also we'll review. I would like to leave about 15 minutes at the end of the period for you to start on the calculator portion of the quiz. And that would just shorten the amount. So that means you don't have to worry about, I have 2 parts of this quiz. It's just a front page is all it is. And it's not too much. So that's what I have planned. Any questions for me, my friends? I'm going to stop recording now, if that's okay with you.